So we've traveled south out of Gadsden to an area called Colvin Mountain, and this mountain runs continuously for several miles near the town of Glencoe, and it continues north. It strikes almost straight north coming out of Alexandria and Glencoe, and then turns east-west until it terminates a couple miles to the east of us. Both ends are fault cut, so this mountain is an isolated component here, and it has a somewhat unique stratigraphy. The Pennsylvanian section is almost entirely gone. There's a little bit of those muds that are underneath the Pottsville that is present here, that direction, and so we've come down section from that, the Pennsylvania Mississippian section, which is the Parkwood Formation. So coming down section, we've gone through some Mississippian rocks. There's Mississippian limestone. There is a chert, the Fort Payne chert. We've continued down, and then we hit this somewhat uncorrelatable stratigraphy in here that doesn't really match with several of the thrust sheets around us to both the north and the south. And so this interval here is called the Greensport Formation, and it's interpreted as Ordovician. And the reason is, if you go down the road, which is down stratigraphy, there are some limestones that are, I think, at least seem like they correlate to Ordovician limestones elsewhere. The Lenore limestone, the Little Oak limestone, some of those Ordovician limestones that you can correlate over long distances, those appear to be present down there. But once you come up here, you get the Greensport here, and you get a little sand, if you can see it up there, called the Colvin Mountain Sandstone. And those have been tentatively correlated as Ordovician and mapped as such, but they're just not present on other thrust sheets. So there has been a little bit of geochronology done on these units and some paleo-mag studies specifically done on the north, or the Greensport here. But the Colvin Mountain sand up there, the geochronology tells us two interesting things. One, we found uranium, or there are zircon with uranium lead ages that are younger than Ordovician. They're Silurian. Now they could be outliers, that's possible, but we've had several other samples from the Colvin Mountain continue to return these kind of 410s, 415 MA ages for the youngest grains. Now it's only a handful, but they are there. Now interestingly also, we have some uranium, thorium, helium ages of zircon from the Colvin Mountain, and several of those grains also returned 410-ish MA grains, and that rock was not heated hot enough to reset the helium in zircon. So how old is that rock? Well, the geochron kind of makes it seem like it's potentially 410-ish or even younger, but stratigraphically it's kind of been correlated with Ordovician. The overlying stratigraphy is not much help. There is a sequence above this that was interpreted to be the Ordovician Sequatchie Formation, which is more distinct either north or northeast of us. But it just doesn't look the same. There's not as much limestone. In fact, there's almost no limestone in the Sequatchie here. The Silurian Red Mountain has been to be interpreted just up above us, and that may or may not look somewhat like the Red Mountain, interbedded sandstones and shales. But this stratigraphy just doesn't match anything else, and the geochron kind of puts us into a bit of uncertainty. But what is interesting is the geochron does tell us that the sandstones up there, and to a lesser extent some of these interbedded silts and sands down here, they contain large proportions of Grenville age grains, about 1 billion, 1.2 billion, and then lesser amounts of the older 1.5 billion and other older populations, with a handful of those Paleozoic grains.